In this lesson, we're going to go over friction loss. And this is the fourth factor of water hydraulics. We've spoken before about the other three factors: pressure, flow, and velocity. And friction loss is the fourth factor. And we've also spoken about the relationship of these, that they're all intertwined, that if you have more pressure, if you take the same setup and you put more pressure through it, it's going to push more water, meaning it's going to have more flow, more volume of water passing through the pipe over the same amount of time. But that also means that the velocity necessarily has to go faster. The water has to go faster through that pipe to match that increased flow. And it's also going to give you more friction loss. And that's why we try to use best practices when we design an irrigation system. When we're doing the design of it and calculating everything out, we want to be precise in what we're doing because we're trying to control the velocity, and therefore we're trying to control the friction loss. Now, the definition of friction loss is the loss of pressure as water in motion passes over the insides of pipe and the fittings. Now, there's four factors of friction loss. The first is velocity, which we spoke about in the previous lesson. The second is the inside diameter of pipe. So if we're using or we're desiring the same amount of flow and we're going to use a 1-inch pipe, it's going to have a certain amount of friction loss. But if we move up to an 1.25 or an 1.5 pipe for the same amount of flow, it's going to have less friction loss because proportionately inside the pipe, you're going to have less of the surface of the water touching the inside of that pipe. Now, best practices in irrigation design, we want to use exactly the right size of pipe just to control costs. If you look at the cost for you using a 1-inch pipe versus an 1.5-inch pipe, you'll see it's quite dramatic. So really what we're trying to do in best practices is only design and only use the exact size of pipe that we need to use. The third factor is the roughness of the inside of the pipe type that you're using. And when you look at the friction loss charts, and we'll go over that in the next lesson when we learn how to read a friction loss chart, but you're going to see at the top of the chart the C factor for that type of pipe that you're using. And it's different for PVC, polyethylene, copper, steel. You got to be a little careful with copper because there's three different types of copper, K, L, and M, that's used in plumbing systems, and they're all slightly different. Some is a thinner, some is a thicker wall. So a lot of the friction loss charts only have one type of copper. You have to go to the internet and find out the different types of that. And some copper is smoother than others. So we're going to kind of leave that alone. But as we look through this, and I know as you like you say, you pick up a piece of PVC and you look down inside the pipe, it looks so smooth. And you think, how could it really have any friction? But it does, and it's calculatable, right? So let's get into some calculations on that, and let's look at the difference at three different kinds of pipe. We're going to take the example of a 3/4 inch size of pipe at 8 gallons per minute of flow. So let's first look at PVC, which has a C factor of 150, and it's going to be the smoothest of these type of pipes that we talk about, and it has a friction loss of 2.85 psi of loss per 100 feet of pipe. When we look at these friction loss charts and you're looking at the friction loss column, these values are for 100 feet of pipe. So let's not get it confused and think that that's only for a foot of pipe. It's for 100 feet. And we'll talk about that a little bit more in just a second. But polyethylene, which has a C factor of 140, for 100 feet of pipe, it's going to lose 5.84 psi per 100 foot. Steel has and this is galvanized steel, it has a C factor of 100. And for that same 100 feet of pipe, it's going to have 10.89 psi of friction loss. And our fourth factor is the length of the pipe. So this is cumulative. For every foot of pipe that you're using, it increases, right? That's why they give you the value in 100 feet of pipe. And so how we're going to calculate that, let's say that we're using polyethylene And instead of 100 feet of pipe, we're only going to use a 60-foot run of that. So what you would do is take your friction loss value of 5.84 and multiply it times 0.6. And that would give you 3.5. And that would be 3.5 total friction loss for that 60 feet of pipe. But let's say that we're only using 6 feet of pipe. We would do the 5.84 times 0.06, and that would give us 0.35 psi loss just for that 6-foot section of pipe. And so when we get into designing irrigation systems, what you're going to have to do is make the calculation for your longest zone, your zone that uses the most pipe, or the longest run from the beginning to the furthest head, and you're going to calculate all the distances. So this is going to be important as you start to install and design irrigation systems. Now we're also going to make smart choices with our fittings and know that some choices are different than others. Let's say that you have to step down from a 1-inch pipe to a 3/4-inch pipe. And as we design irrigation systems, we're going to use what's called the pipe sizing method, meaning that as each head goes by, as you go out into the zone, you're going to need less flow, because if you start off and you have 6 heads in a zone, and then once you pass that first head, now you only need flow for 5 heads and then 4 heads. So we're only going to use exactly the size of pipe that we need to carry that flow. And it actually helps us to balance out the pressure and the flow throughout the zone. So if you're at the very limit, let's say you're working with low pressure and you're trying to design this thing out perfectly, some of your choices is going to make a difference in, let's say, that situation where you're having to step down from 1 inch to 3/4 inch. You could use a coupling, just a straight coupling, and a bushing 1 inch by 3/4 inch bushing. Well, that has a lip, and it's going to cause you more friction loss. I don't have a calculation for this, it's not in the charts, but it's going to cause you more friction loss than a step down coupling, or a reducing coupling, I think it's generally called in the books, which has just a sloped surface on the inside that slopes down versus that rigid lip of pushing a bushing into that coupling. And also, if it matters, and it's not always feasible to do this, but a 90-degree elbow has more friction loss than 245-degree. So I know that that's not always feasible to use 245s versus a 90-degree elbow there, but these little small choices do add up.